Not understanding the long-term capability of your process is like driving your car at night during a snowstorm. Visibility is very poor and driving is hazardous. However, knowing and understanding the long-term performance of your manufacturing process is like driving your car on a nice sunny day. You can easily see the road and drive confidently between the lines. Capability studies statistically compare real-life process variation to product specifications. Long-term process capability is measured by PP and PPK. As the name indicates, long-term studies includes process performance data that's collected over a long period of time, such as a month, for example. It's common to collect hundreds or even thousands of data points for use in a long-term study. To decide what product features to study, start by looking at customer complaints, defect rates, and competitive products. You want to study and improve process variation with the intent of reducing costs and improving the customer experience. The data you collect should include all the typical input variables, ones that impact your ongoing process, such as raw material lot changes, operator adjustments, and environmental fluctuations. It is the process variation caused by these things that you want to characterize and improve. If you're lucky, you already have study data available in the form of ongoing quality records. And if you have this information, the only other thing you need are your product specs. After data collection, the next step is to enter the data into a statistical software package, such as Minitab or Excel or a free online calculator. And then you want to generate the study results. Now, to interpret the study results, follow these steps. First, let's understand PP because it reflects the process variation as compared to the product specs. The greater the PP, the greater the process sigma level, and the lower the defect rate. So again, the greater the PP, the greater the process sigma level, and the lower the defect rate. And you can see at a 6 sigma process level, the PP is 2.0, and the defect rate is 3.4 units per million. And that represents 99.99966% defect-free product. However, if PP is less than 1.33, then you're at risk of sliding off the process road into defect land. So you want to aim for a PP of 2.0 because 6 sigma is the gold standard of process management. Second, let's compare PP results to PPK results. We do this because PP doesn't change if the process isn't centered, but PPK does change. So if PPK is lower than PP, then we know our process is running off-center. And an off-center process yields more defects than a centered process. So of course, if you see this, you want to center the process to correct the issue. Third, using the results of the long-term study, compare PP to CP. If there is a difference between these measures, then run a time series graph. And here you want to look for process shifts in your data. Maybe different operators are adjusting the process differently. Or maybe raw material lot changes are affecting your process. Whenever you see a difference between PP and CP, it means that your process is shifting. And you definitely want to get to the root cause of these process shifts. Fourth, compare the results of your long-term process capability study to your short-term study results. The difference between these two different studies indicates your process opportunity. The concept is that if your process can perform at a high level under ideal short-term conditions, then why can't it be done every day? My name is Joe Joyce and I'm with Tools for the Trenches. If you work in manufacturing, then visit us, follow us, and subscribe to thrive.